In this video, we look at this MIT Integration B question. This appeared in the 2025 qualifying round. So we can solve this integral by splitting this integral into two different integrals, right? So we are going to use integration by parts, and I will do that in a moment. So let's start off by splitting this integral into two different integrals. Sorry for this. So splitting this one into two different integrals, we have I to be equal to the integral of, we have x ln of x cosine of x divided by x ln squared of x dx. This is one integral minus the integral of sine of x divided by x ln square of x dx. This is the second integral. Let's look at the first one again. So there will be some cancellation. See that x here will cancel x, and then ln of x is going to cancel 1, leaving 1 ln of x. So that is going to be left with the cosine of x at the numerator divided by the ln of x dx minus the integral of sine of x divided by x ln square of x dx. I am going to use integration by parts for the second one, so let's do that here. So let's do the DI method. That is what I always do in my videos. DI, so D for differentiation and I for integration, right? I am going to differentiate the sine of x because it's very easy to differentiate sine of x, and I'm going to integrate the rest. The rest will be 1 all over x ln square of x dx, right? So this plus, next one is minus. If you are differentiating sine of x, that is going to give you cosine of x. And if we are integrating this guy, we can do a u sub here real quick, right? So we can let u to be equal to the ln of x. So if we let u to be equal to the ln of x, that is going to be equal to what really? So that is now going to be the integral. So if we differentiate this, du is going to be 1 over x dx, right? So if you are now integrating 1 over x ln square of x dx, this is now going to be the integral of 1 all over ln square of x multiplied by 1 over x dx, right? So this one is going to be the integral of 1 all over ln of x is u, that is from here, so by squared, so that is u squared, and then 1 over x dx is the same as du, so just replace with du. So integrating 1 over u squared is going to be negative 1 over u, and then we plug in back u. What is u? U is going to be the ln of x, so that is going to be negative 1 all over ln of x. So if we are integrating this one, the answer to that is going to be negative 1 over ln of x. So I'm just going to write that here. Negative 1 all over ln of x, like this. And I will erase this one now. So I'm now going to clean this one. So we are done with the integration, and then what we normally do is when we multiply terms diagonally, we don't need to take the integral. But when we multiply terms horizontally, we have to take the integral. So this is what we have been doing. So our integral r here is going to be the first one, the integral of the cosine of x all over ln of x dx minus this integral is now multiplying terms diagonally. That is going to be negative sine of x all over ln of x. Then if you are multiplying terms horizontally, we have to take the integral, but be mindful of this negative and this negative. When you multiply them, that becomes positive, so that's going to be the plus the integral of cosine of x divided by the ln of x and then dx. This is using integration by parts for the second one. So this is the integral of the cosine of x all over the ln of x dx. So plus, so this minus and this minus becomes plus, and then we have sine of x over ln of x. Then minus and positive, that becomes negative, the integral of the cosine of x all over the ln of x dx. So this one cancels this because they are the same. One is positive and one is negative. So your integral is just left with sine of x over ln of x. plus c. So that is the value of this integral. So therefore, if we integrate x ln of x cosine of x minus sine of x, all this one divided by x ln square of x dx, this one simplifies to sine of x all over ln of x plus the constant of integration. This is the answer to our integral. That is how I can solve this integral. If you know an easier and faster way to solve this, please leave a comment in the comment section and let me know what you think. Anyway, I thank you so much for watching this video. If you find that helpful, please give me a thumbs up and subscribe to Calculus Diaries for more engaging content on integrals. I thank you so much and I'll see you in the next one. Bye bye.